Okay, guys, this question is also asking you to figure out a final quantum state. It says an electron in a hydrogen atom is in the n equals 7 quantum state, and it emits a photon with a wavelength of 397 nanometers. What's the final quantum state after it emits the photon? And so not only do you have to have good algebra skills, you have to know that you have to use the Rydberg formula, but you also have to have a conceptual understanding that the photon is emitted. And so what that means is that the electron loses energy. So again, what that means is if it loses energy, it goes from an n equals 7 to an n equals question mark quantum state. But what do we know about that question mark? We know that it's a lower quantum level. And so we have to have that understanding to put together the Rydberg formula correctly, because remember that the quantum values are 1 over NL squared minus 1 over NH squared, where NL is the lower quantum level and NH is the higher quantum level. And so this is the one, the NL, that we're going to be solving for. So in the next time I write it down, I'll call it X. So now I can kind of start putting things together. 1.397 times 10 to the negative 7 meters is what the wavelength is, so 1 over that. And that equals the Rydberg constant, 1.097 times 10 to the 7th per meter, equals 1 over x squared minus 1 over 7 squared. And 7 squared was our quantum value that it started at in the problem. And so 1 over 7 squared would be 1 over 49. So go ahead and taking 1 and dividing it by the wavelength, I get 2.5189 times 10 to the 6th meters to the negative 1. And so that equals 1.097 times 10 to the negative 7th minus meters to the minus 1 times the quantity 1 over x squared minus 1 over 49. So I can take the left side and divide it by 1.097 times 10 to the 7th meters to the negative 1. And I end up with 0.22966 without any units. And so if I take meters to the minus 1, I divide it by meters to the minus 1, the units cancel and I'm left with something that's unitless. And that's good because ultimately I'm solving for a quantum state and quantum states don't have units. And so on the right side, I'm just left with 1 over x squared equals minus 149. So if I add 1 over 49 to both sides, I get 0.25007 on the left side, and that's equal to 1 over x squared on the right side. Now, I want to solve for x squared, ultimately to solve for x. So I'm going to go ahead and take the inverse of both sides in order to get x in the numerator. And so I end up with x squared equals 3.9989. And when I take the square root of that, I get 1.999. And so I see that x equals 2. So the final quantum level is 2. So the electron went from n equals 7 to n equals 2. Okay, that's it, guys.